Welcome to our tutorial about geometric continuity. We've talked about this previously, and in this tutorial, I'm going to show you in more detail how it works. Understanding and applying curvature principles is critical during surface design and modeling, for example, when you're transferring your CAD data to another CAD application. Here we're going to learn about another curvature measurement type, geometric continuity. In our previous lesson about curvature, we learned that curvature is an expression of a non-planar face, or in other words, a face that's not flat. So, to remind you, a planar face has a curvature value of 0. When your analysis shows you a curvature value of 0, you know that your surface is flat. Geometric continuity is something different. In CAD systems, the smoothness of your surface is defined by its geometric continuity. We can describe geometric continuity as follows. G to the power of n, where n is the measure of smoothness. In this tutorial, we're going to look at the 3 curvature standards that we've touched upon briefly earlier: G0, G1, and G2. Now, you may have heard talk about parametric continuity and geometric continuity. For the purposes of this lesson, I'm going to use C and G interchangeably, where C stands for parametric continuity and G stands for geometric continuity. Okay, in model space, I've got an example of G0 continuity. This is also known as positional continuity. You may hear it described this way too. G0 means that the ends of 2 curves or edges of 2 surfaces share a common position in space, but no tangency is present. What you end up with is a sharp angle or transition. There's a quick way to get rid of the sharp transition between these 2 lines here. You guessed it, we can apply a fillet. And when you apply a fillet, tangency is present. Let's activate the fillet command. You'll remember that it's on the Modify panel. Let's right-click and select Radius. Enter a value of 0.5, press Enter to accept, and now select the 2 lines to which you'll apply the fillet. Tangency is an example of G1 continuity. You might also see G1 described as tangent continuity. G1 is where 2 curves or surfaces share a common point or edge in space, and they also share tangency. And I'll just repeat that so it sinks in. G1, 2 curves or surfaces share a common point or edge and tangency. Let's see how we can improve the smoothness of this transition. The greatest level of continuity we can achieve between an arc and a line is G1, or tangent continuity. That's where the arc and the line share a coincident point and a tangent constraint has been applied. However, if we replace our straight line with a spline, we get more options. Let's copy our geometry. I'll select the line and the arc. Next, we'll activate the Copy command. Specify the base point and the Move To point. Right-click and Enter to close. Something like this. Now let's trace the line with a spline. 2-point spline. Right-click and Enter to close the spline tool. A spline between 2 points is effectively a straight line, so how is this any different? Well, when you use a spline, you end up with a tangent relation between the spline and the arc. So this gives us the option to apply G2 geometric continuity. Let's go to the Parametric tab and select Smooth Constraint. First we select the spline, then the arc. What you see here is an example of G2 geometric continuity between the spline and the arc. With G2 geometric continuity, the transition between the spline and the arc is continuous curvature. Let's learn how to make it even smoother. Let's go back to the Home tab and modify our geometry a little bit. Activate the Spline command. I've got Snap Mode toggled on. I'm just going to trace my geometry with the Spline command. Right-click and Enter to close the tool. Let's zoom in a little bit. The more spline points we've got, the closer the spline matches our original geometry. Let's select and drag the spline out to its own space. And of course, this spline is another example of G2 geometric continuity. Let's create some surfaces now. Extrude. Select our objects. Right-click, select Mode, Surface. Now we specify the height of the extrusion. Remember, I didn't actually have to right-click and select the Mode option to end up with surfaces because we've got open profiles here. It's just basically a habit. Let's make a 1-unit extrusion and press Enter. Take a home view, realistic view style, and let's go to the Surface tab. Analysis Options, Zebra Stripes. Select the objects to analyze. Right-click to finish our selection. Type Chrome Ball. Size, let's use thin. And click OK. Now we can see the differences between the continuity types. Here we've got an example of G1 continuity. Here's G2, and G2 here as well. As you see, the surfaces on the bottom have much smoother transitions. And this concludes our lesson about geometric continuity. In our next few lessons, we're going to take a look at some of the other tools AutoCAD gives you to create and modify surfaces.